Almost afternoon, Algebros. This is Mr. Jeffries coming at you again for Algebra 2. Don't forget, hit like and subscribe to the bell. Today we're talking about exponential functions. This is basically the same way that y'all spread rumors in high school. Okay, if you tell two friends and you tell two friends and so on, that's how it gets covered. Same algorithm is used in social media called going viral. Okay, now back in my day, going viral meant that you had something that Ajax wouldn't take off. But this is a whole new thing. All right, so here's the deal, pickle. So growth. Here it is. We have y equals a dot b to the x, or this right here. You'll actually see more of this right here because it's easier to write. Okay, so many people jack up the dot right here. Okay, when it's handwritten, they'll try to do like it's a decimal, and it just doesn't work that way. All right, so what we're talking about today is its growth when the b, that's this one right here with the x, is greater than 1, and its decay when the b is between 0 and 1. Okay, you can't say when it's a fraction, because I think I've put some on here before that it's a fraction, but it's above 1. Okay, so let's look at this right here. All right, so a is the first number after the equal sign. So on number 1, what is our a? 3. What is going on here? Okay. All right. What is our b? 2. All right. Because our b is 2, is this growth or decay? Growth. Because 2 is greater than 1. Okay. Shh. So, number 2. All right. So, what is our a for number 2? No, our A for number 2 is not B. Okay. Good try. Okay, so what is our B?
0.5.
Okay, now our B, yes, it's going to be decay because it's between 0 and 1. Okay. You would think so. All right, what is on 3? What is our A? There's a couple of different ways. The traditional way is 1,200. The southern way is to say 1,200. Okay? So, all right. What is B for number 3?
1.03.
All right. Is 1.03 greater than 1 or between 0 and 1? Greater. So this would be growth. All right, number 4. What is our A? 14. What is our B? All right. Is this growth or decay? Growth. Because 1.5 is bigger than 1. All right. Number 5. What is our A? 14. What is our B? 0.1. So is this growth or decay? Decay. And if we were going shopping, it would be DG. But anyways, all right, so number 6, what is our A?
100.
What is our B? 2/3. Okay, so because our B is 2/3, is this growth or decay? Decay. Okay.
Oh, darn it, I gotta look. Hey, you know when you put that fraction in, it gets...
I know, it gets...
7.
Yeah. It's so funny. Hey, to whatever. Apparently, I'm being recorded for a vlog as I'm recording, so it's like recordception or something. Okay, anyways. All right, we're going to pause briefly as they do this your turn, and then we're going to go over it. So just hang on. We're coming right back. All right, so we had a little hiatus as we did this. So we're looking at number 7. So our your turn says state whether they're exponential growth, decay, or neither. Okay, so we're looking right here. This is greater than 1, so this is growth. Okay. This one is decay. This one is neither. Now, so here's the deal, Pickles. If it's an exponential function, x is the exponent. Wow. Okay, that means x is like the little number getting like a piggyback ride. Okay, and then number 10, this would be growth or decay. Decay. All right, so that's good thing about that. So got 1 through 7.
When you're multiplying exponents, don't you just like add them together? It's adding. I thought so. And then dividing them is
It's subtract. Yeah, we're getting there.
All right.
We're not there yet.
I am. Valerie's there.
All right, so example 2. Write an exponential function by first identifying the initial amount, growth decay factor, and then evaluate. All right, so our initial amount, this is our A value. This is our B. Okay, so initial amount in a single elimination tournament starting with 128 teams, half of the remaining teams are eliminated in each round. So how many? What is our initial amount?
128.
Yes. All right. So our decay factor, because it's getting smaller, half. How do you write How do you write the word half as a fraction?
1/2.
All right. So it says now use parts A and B to write a function. Okay. So this is literally our A. That's our B. So we would say y equals 128 parenthesis 1/2 x. Okay. Now, number D says how many teams will be left after 5 rounds. Okay, so that means that we have to do this. 128. Now, in the calculator, you would actually type it in like this. I know a lot of y'all would do this right here. That's, yeah. So 0.5, raise the roof to the 5th. Okay, so after 5 rounds, there'll be 4 teams left. Now, is there anything in the world where this is similar to? Where, like, we start with a lot of teams, and each round we have half that goes to the next round. Might be happening coming up in March. Basketball, yeah. You start, instead of starting with 128, you start with 64. So this is actually, there is a mathematical way to write how a tournament works. I know, it's riveting. Yep. All right, so we're going to pause for your turn. All right, so we're going to come back and we're going to be looking at this one. All right, so we invest $8,000 in a certificate of deposit or a CD that triples every 7 years. So how much do we start off with? 8,000. No, 6 or 7 is about how many brain cells y'all have. All right, so the growth factor would be triple, so this would be 3. Okay, so our function okay, now here is where we get to the next part. All right, it only triples every 7 years, so we're asking for 21 years. So how many times does every 7 years happen in 21? 3. So we actually are going to plug this in. 3 to the third power. Well, you have to think a little bit outside the box in this one. Some of y'all are like so stuck in the box, you're like a Schrodinger's cat. All right, so now here's the bad thing. All right, think about it. You put in $8,000. After 21 years, you only get $216,000. No, that is horrible. Okay? There's other money market accounts that you could actually have this much money after less than 3 years. Okay, so a CD, like basically it's closed. It's a deposit. You can't, I mean, you can get it out, but there's penalties, but it only gets a little bit more interest. Okay? So CDs are okay for short-term things, not long-term. Okay? All right. To the back. So, now, if you've always wondered what that E thing is on the calculator, this is what it is. Okay, also, if remember, if stuff doesn't make sense in math, what do we blame? Opium, because that is what they used as their natural everyday thing. All right, so it's exponential growth if both the A, which is this number here, and the R, this number here, is bigger than 0. And it's decay if the A is greater than 1. All right, so let's look at this. All right, so our A for number 1 is 1/2. Okay? Our R, this is the number in front of X. What is the number in front of X when it's just X? 1. Okay? So both of these are greater than 0, so this would be degrowth. This would be the growth of the stuff. All right. Now, number 2. So, our A is 4. Our R, this is the number, what number is in front of X if it says negative X? Negative 1. Awesome. So because this R is negative, guess what? Yeah. Both of them positive, it's growth. 1 negative, decay. All right. Number 3, our A is 2. All right. Our R is, see, what's this number right here? Oh, all right. So if we have 2 and we have 2, yeah. Crazy. All right. So this is the part where we hadn't really covered the rules of exponents yet. And then our newest edition was going full speed into that, and a lot of people are like, where? Now, so here's right here. If this is multiply, we add the exponents. All right, so this becomes e to the 3 plus 6, okay? All right, everybody, ready? What is 3 plus 6? All right. All right, when it's divide, guess what? We subtract, not sud, the exponents. So let's do this first. We have 16 over, oh my gosh, dyslexia. 16 over 4, which is 4, okay? And then we have e to the 5 minus 4. So if I have 5 e's and I subtract 4 e's, yeah. Now you could write it like this or this. This is a power to power. Valerie, what do we do for that? Do you remember? Do you remember when it's a power to a power, what do we do? Yeah. Alright, so let's look at this. This is all this squared, so that means basically we could write it like this if we wanted to. If you don't want to, don't write this down like this. Alright, so or I like to say this is like distributive property on steroids. So 3 squared and then e to the negative 4x times 2. Alright. So what is 3 squared? What is 3 times 3?
9.
Okay. What is negative 4 times 2? Negative 8. Alright. Now, we're actually going to stop the lesson right now, and we're going to step through these other ones together, maybe. And then tomorrow we might have a mini lesson before other stuff, because technically y'all should have had the exponent rules before, but that doesn't mean anything if you learned them like May of your, 9th grade year or something. So, alright, don't forget, hit like, subscribe, hit the bell. Good stuff, good things.
Roll Tide.
Roll Tide.